Hello everyone, welcome to Geeky Nerd. Today we will begin a new aptitude topic called Problems on Trains. Before moving into the video, I hope everyone would have become thorough with the previous aptitude topics, that is, averages, ages, and time, speed, and distance. The aptitude topic of problems on trains has been divided into several parts for the convenience of the listeners. If you have not seen the videos of the other aptitude topics, please click on the cards or the link in the bio. In this video, we will be discussing the concepts of relative speed as well as how to determine the time, speed, or the distance when trains cross stationary objects. Like, share, and subscribe the channel for more interesting concepts and shortcut methods for solving the problems. So without wasting any time, let's move into the video. Let us give a quick revisit to the concept of relative speed. So relative speed is nothing but the speed of one object with reference to the position of the other. We discussed about this concept in the time, speed and distance aptitude topic. This concept involves two cases, namely, in the first case, we deal with the two objects that are moving in the same direction. When two objects move in the same direction, then the relative speed can be defined as speed of first object difference speed of second object. Here, whichever object has larger speed, that can be used as the first entity. When two objects move in the opposite direction as given in case 2, the relative speed becomes additive in nature. Therefore, relative speed is equal to speed of object 1 plus speed of object 2. Let us solve one problem quickly to recap how this works. Two trains 180 meter in length are running in the same direction. The first train runs at the rate of 51 meter per second and the second train runs at the rate of 42 meter per second. Find the relative speed. So from the question we can see that speed of train 1 is equal to 51 meter per second and speed of train 2 is equal to 42 meter per second. We know that from the question both the trains run in the same direction. The relative speed can be given as speed of train A difference speed of train B, which is equal to, since speed of train A is higher, 51 meter per second minus 42 meter per second, which is equal to 9 meter per second. Therefore, when the two trains whose speed are 51 meter per second and 42 meter per second respectively, when they move in the same direction, the relative speed becomes difference in nature. Therefore, relative speed is equal to 51 minus 42 meter per second, which is equal to 9 meter per second. Had they moved towards each other, then relative speed would have become additive in nature. Train crossing a stationary negligible object. If a train crosses a stationary object such as man, pole, tree, or milestone, then we can say that the distance traveled by the train to overtake that stationary object is equal to length of the train. So in this concept we deal that a train is crossing a stationary object. It can be a man who is standing still or a pole or a tree, etc. Then the train has to travel a certain distance to overtake that stationary object. So that distance is given as distance is equal to length of the train. In general, when it is having multiple objects such as train and another stationary object, the length of the stationary object should also be considered. But the object remains stationary and therefore the length widthwise will be very negligible in nature and hence length of the object becomes negligible and therefore we directly take the distance as length of the train itself. So once we know the length of the train, we can determine the time taken by the train to cross the particular stationary object. From time, speed and distance, we know that speed of the object is equal to distance traveled by time taken. Therefore, time taken by the object is equal to distance traveled by speed. Here, time taken by the train to cross the stationary object is equal to distance traveled, that is length of the train in this case, divided by speed of the train. So, whenever a train tries to cross a stationary object, these formula can be used to determine the distance traveled by the train to cross the object and the time taken by the train to cross the object. Let us solve few examples to understand this. A 300-meter long train running at a speed of 72 km per hour goes past a pole. What is the time taken by the train to cross the pole? So from the question, it is given as length of train is equal to 300 meter. Speed of train is equal to 72 km per hour. We need to find time taken by the train to cross the pole. So we know that distance traveled by train to cross pole equal to length of train L suffix T plus length of pole L naught. So we know that length of the pole widthwise is negligible, therefore is equal to length of the train. That is, distance traveled by the train to cross the pole is equal to length of the train. Henceforth, we know that time taken by train is equal to distance traveled by the train to cross the pole divided by speed of the train. Here distance we found as 300 meter, whereas speed remains 72 km per hour. So we know that when we convert speed from kilometer per hour into meter per second, we have to multiply it by 5 by 18. Therefore, in the denominator, 72 into 5 by 18, which in turn will get cancelled and give us 300 divided by 20, which is equal to 15 seconds. Therefore, the train takes 15 seconds to cross a pole, and the length of the train is 300 meter and the speed of the train is 72 km per hour. Let us solve one more problem. A train takes 9 seconds to cross a pole. If the speed of the train is 48 km per hour, find the length of the train. Time taken is equal to 9 seconds and speed of train is equal to 48 km per hour. So, we need to find length of the train. We know that distance traveled by the train to cross the pole is equal to length of the train. Therefore, if we find the distance from the speed and the time taken given in the question, we can compute length of the train. We know that distance is equal to speed into time taken. Therefore, we know that speed as 48 km per hour. Since we want everything to be the same metric unit, we are converting speed into meter per second. So 48 into 5 by 18 multiplied by 9 seconds. Upon solving, we get 24 into 5, which is equal to 120 meter. Therefore, if the train takes 9 seconds to cross a pole at a speed of 48 km per hour, then the distance of the train is equal to 120 meters. So, in this concept, we dealt with the train along with a stationary negligible object. Let us move on to the next concept, train crossing a bridge or a tunnel. So, the only difference between this concept and the previous concept is that there the train was crossing a negligible object. Here, the train is crossing an object which is of substantial length, and hence the length of the object cannot be neglected. If a train crosses a stationary object such as bridge or tunnel, then the distance traveled by the train to cross that object is equal to length of the train plus length of the object. Similarly, we know the formula of time taken, that is time taken is equal to distance by speed. The time taken by the train to cross that object is equal to distance traveled by the train divided by speed of the train, which is equivalent to length of the train plus length of the object divided by speed of the train. Thus, in this concept, since the train crosses an object whose length is substantial, it has to be included while calculating the distance traveled by the train. Let us solve some examples to understand this concept. A 300-meter long train has a speed of 10 meters per second. How long will it take to pass a platform of 50 meters? So from the question, we understand that length of train is equal to 300 meters. Speed of train is equal to 10 meter per second, and length of platform is equal to 50 meters. We need to find how long will it take to pass a platform of 50 meters. So we know that time taken is equal to distance divided by speed. This is the basic formula of time taken. Whereas in this case, distance is equal to length of train plus length of the platform. Since the platform's length cannot be neglected, we have to consider it in the case of distance traveled by the train. Therefore, 300 plus 50 will give 350 meters. So now we know the speed of the train along with the distance traveled by the train. Therefore, time taken is equal to 350 divided by 35, which is equal to 10 seconds. Therefore, the train takes 10 seconds to cross a platform of 50 meters at a speed of 10 meters per second. Let us solve one more example. A train moving with uniform speed crosses a pole in 2 seconds and a 250-meter long bridge in 7 seconds. Find the length of the train. So from the question, we can understand that time to cross pole is equal to 2 seconds. Time to cross bridge is equal to 7 seconds, and length of the bridge is equal to 250 meter. We need to find length of the train. So we can use the same formula, that is time taken is equal to distance by speed. So here we don't know the distance as well as the speed. So first we need to determine speed of the train. So speed of train is equal to distance by time. So, speed of the train can be determined using the time the train takes to cross a pole. Here, distance is not given, therefore, it remains d, and time taken by the train to cross the pole is equal to 2 seconds. Therefore, speed of the train is equal to d by 2. We will retain this as equation 1. So, time taken is equal to the distance traveled by the train can be written as length of train plus length of the bridge, the whole divided by speed of the train. By substituting equation 1 here we get length of the train we don't know, we will keep it as LT. Bridge length is 250 divided by D by 2, and the time taken is given as 7 seconds. This in turn can be written as twice of LT plus 250 is equal to 70. So here D refers to the length of the train. Therefore, twice of LT plus 750 is equal to 7 LT. Therefore, 5 LT is equal to 500. LT is equal to 100 meter. So by solving this question, we found out the length of the train is equal to 100 meter. The only point which we need to be aware is whenever a train crosses a stationary object whose length is substantial, then the length of that object should also be included while calculating the distance traveled by the train. Through this video, we had learned the definition of relative speed, how the speed varies depending upon the direction of the objects. We also learned how to calculate the time taken, distance traveled, or the speed whenever the trains cross stationary objects. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can also be benefited. Until we meet in the next video, thank you.